All right, hello once again, Jeff Scott of Rankin Technical College. And as part of the Rankin Technical College Application and Website Development, or AWD1111, database-driven web development course, I've been doing a series of video presentations. I started out by doing a bunch of presentations based on some of the PDFs or handbooks that Mr. Flavio Copes has under his Valley of Code website. I started with these three right here, doing some client-side JavaScript. So I did about 5 from his HTML handbook, about 10 from his CSS handbook, and about 9 or 10, 8 or 9, something like that from his JavaScript handbook. Then I went back to the AWD1000 Web Development Technologies course and grabbed a couple of presentations that I'd done just because they had some stuff in there on JavaScript fundamentals. From there, I went on and I did a bunch of videos based on Brad Traversy's Web Dev Guide, Mr. Traversy being a self-taught web developer extraordinaire in my opinion. So I have gone through the HTML handbook by Mr. Copes. I have gone through the CSS handbook from Mr. Copes. I have gone through the JavaScript handbooks from Mr. Copes. And I am about halfway or so through the Node.js handbook from Mr. Copes. Now, I do want to mention something, and it probably is pretty obvious to you, but none of these handbooks are all-inclusive. So in other words, they give us a good start, but this doesn't necessarily mean that every single thing that you need in order to really learn this stuff and learn it well is going to be in these particular handbooks. All right. So the next section, as you can see, is on the Node.js event loop. This is one of the, I would say, more core concepts of JavaScript and about JavaScript and Node.js, and probably one of the harder ones to understand. So it says there, why is this so important? Because it explains how Node.js can be asynchronous and have non-blocking I/O, and it also explains the killer feature of Node.js, the thing that made it so successful. Node.js, as it says there, code runs in a single thread. So there is only one thing happening at a time. That said, Node, as it has to, can switch back and forth between things very, very quickly. You do have to pay attention, as it says, to how you write your code to avoid anything that could block a thread. Things like synchronous network calls, infinite loops, anything that's CPU intensive, like a lot of CPU intensive calculations, etc. So as mentioned there, in general, in most browsers, there is an event loop for every browser tab to make every process isolated and avoid the web page from running into bad situations. The environment manages multiple concurrent event loops. You need to be concerned that your code will run on a single event loop and write code with this type of thing in mind. There'll be several pictures in here, some of which may make total sense to you, some of which you might struggle with. So, any JavaScript code that takes too long to return control back to the event loop will block execution. Again, as we mentioned, things like very intensive calculations, things like infinite loops. All right. And if that happens, the user can't basically go on. They're kind of stuck in purgatory, so to speak. Almost all the primitives in JavaScript are non-blocking. Blocking is the exception. And this is why JavaScript is based so much on callbacks and more recently on promises and then into async await. We've talked about this. All right, now they're going to talk about several stacks here, and they're going to talk about, there'll be a lot of pictures, pictorial representations of what's going on here. All right, so the first one they talk about is the call stack. The call stack is LIFO, last in, first out. What does that mean? I've given this example before, but this is the way it was explained to me, that basically when you work with a stack, it's like having a stack of trays that somebody puts on one of those spring-loaded mechanisms in a cafeteria. When you push, so the cafeteria worker pushes those trays down, and the person comes up to take a tray, and the last one that gets put in is the first one that they grab, by and large. So as it says here, the event loop continuously checks the call stack to see if there's any function that needs to run. While doing so, it adds any function call it finds to the call stack and executes each one in order. So it says, you know the error stack trace you might be familiar with in the debugger or the console. The browser looks up the function names in the call stack to inform you which function originated the current call. So when something goes wrong, it wants to tell you the most recent thing that happened, and then the next most recent thing that happened, and then the next most recent thing that happened, etc. And that is called basically unwinding the call stack. So they give an example right here. So we've got this thing, the foo, which is going to call foo right here. All right, so it'll console log foo, then it'll call bar, which will throw a new DOM exception. All right. So if you worked your way through here, you could see exactly what called what to get where you were. So the call stack can be an unbelievably important feature when you are trying to work your way through, when you've got errors, etc., when things are not working as planned in the program, that you are able to go through the call stack to try to figure out what happened. All right, a simple event loop explanation. So it says here, let's pick an example, okay? So again, let's follow the code. All right, don't worry about any of this stuff. We have foo, so that's a function call. And it should print out foo, and then it should call bar, which should print out bar. Then it should call baz, which should print out baz. So this should say foo bar baz, and it does. It says when this code runs, first foo is called, inside foo we call bar, then we call baz. All right, it says at that point, the call stack looks like this. So you've got foo, all right, which has that console log. It does that, so it's back to here. It gets bar. It does what's supposed to be done in bar. It comes back. It calls baz. It does what's supposed to be done in baz. It finally finishes up, and then it's empty. Again, that is assuming nothing else is called during that time. So as mentioned here, the event loop on every iteration looks to see if there's something in the call stack, and it executes it on a last in, first out type of way. It says the above example looks normal. There's nothing special about it. JavaScript finds things to execute and runs them in order. It says, let's see how we can defer that until the stack is clear. Well, the way they're going to defer this is they're going to use a set timeout. Even though they're setting the timeout to 0, what's going to happen is when you look in here, okay, it's going to call foo. Foo is going to do a console log of foo, but then there's a timeout. So it's going to immediately jump to baz, and it's going to say baz. When it gets done, it'll finish up, and it'll call bar and call bar. So rather than this being foo, bar, baz, like we had before, it should now be foo, baz, bar. All right. So as mentioned here, when the code first runs, first foo is called. Inside foo, we set a timeout, passing bar as the argument, and we instruct it to run immediately as fast as it can, passing 0 as the timer. Then we call baz. So you can see what happens here. All right, the key thing here is when it gets that set timeout. All right. Now, this isn't the key takeaway from this should be when you go in there, if you want to change around the order in which stuff executes, because you've got something that may take extra time, then what you will want to do is you'll want to set some kind of a timer. Right? That is a way of doing it. So it says, why is this happening? The message queue. When set timeout is called, the browser or Node.js starts the timer. Once the timer expires, in this case immediately, the callback function is then put into what's called the message queue. The message queue is also where user-initiated events like click events, keyboard events, and other things are queued. Notice in the bold there, the loop gives priority to the call stack, and it first processes everything it finds on the call stack. Only if there's nothing left on the call stack does it go over the message queue, all right, and grab everything that's in there. It says we don't have to wait for functions like set timeout, like fetch, like database request that can take some time. All right, it says because they are provided by the browser and they live in their own threads. For example, it says if you set the timeout to 2 seconds, you don't have to wait for 2 seconds. All right, the wait happens elsewhere. ECMA 2015 introduced the concept of what's called the job queue. As it says, the job queue is used by promises, which were also introduced around that time. It's a way to execute the result of an async function as soon as possible, rather than it being put at the end of the call stack. Promises that resolve before the current function ends will be executed right after that function. All right. And it says here, similar to a roller coaster ride at an amusement park, the message queue puts you in the back of the queue behind everybody else, where you'll have to wait your turn, while the job queue is the fast pass ticket to get you on another ride. So as soon as the one that you're riding on is finished, you'd start up another one. So let's see if we can figure this one out. So again, we've got const. We call foo. We print out foo here. Then we've got this. Now this is a new promise that says resolve. All right. And then it should call baz. If I'm right here, it'll go back to foo baz, and it says, so it does foo. All right. It sets a timeout, and it comes down and it does baz, and then it immediately jumps back up here, and it says should be right after baz, but before bar, and then it calls bar. All right. So as mentioned there, that's a big difference between promises and async await, which is built on promises, and plain old asynchronous functions through set timeout. And then they run through what the stack will look like again. All right. I don't know if it helps to go over this. And again, is this the kind of thing you've got to worry about? Let me tell you why you might. All right. The reason that this can be important, all right, is if you are doing a lot of operations where you're making a lot of calls out to a database or something that could take some time, you want to try to set it up, be it through the use of callbacks or promises directly or async await, that things happen in as natural of an order as possible. And really the way that that has happened over time, all right, really the way that that has happened over time is that this has been more refined, more sophisticated, where we've moved from callbacks to straight promises to async await. All right. Understanding process.nextTick. It says as you understand the node event loop, one important part of it is process.nextTick. Every time the loop takes a full trip, it's called a tick. So when you pass a function to process.nextTick, you instruct the engine to invoke this at the end of the current operation before the next tick starts. In this way, as mentioned here, we can tell the JavaScript engine to process a function asynchronously after the current function, but as soon as possible and not queue it. All right. Again, until you start really working with this stuff, it probably doesn't make a lot of sense. That said, are you going to be doing a lot of work with set timeout and the like? The answer is probably not in this program. That doesn't mean that if you get a job as a web developer or as a full stack developer, you couldn't be using this, because you very well could. All right. When you want to execute some piece of code asynchronously, but as soon as possible, one option, I should say, is to use the set immediate function provided by Node. As mentioned here then, any function passed as the set immediate argument is a callback executed in the next iteration of the event loop. So how is it different from set timeout? It says a function passed to process.nextTick is going to be executed on the current iteration of the event loop, whereas it'll execute before anything that's been put in with set timeout or set immediate. And they give yet another example in here. So now they've got start. All right. So that should call start. Then we've got a set immediate. That's Boz. All right. Then we've got a promise. And we are basically telling it to go on here and do the resolve. And then do the next tick. All right. And then come back and do bar. So as it says here, the code will first call start, then call foo in the process.nextTick queue. After that, it'll handle the promises microtask queue. Then it'll call zoo. In the end, Boz will be called. So the bottom line is this. This is something that is not going to make a lot of sense looking at pictures and listening to an instructor read things to you. You have to sit and try this stuff. Okay? All right. They talk next a little bit in here about some of these things. So notice there's set timeout. As it says, the job of set timeout is to delay the execution of a function. You specify a callback function to execute later and a value expressing how much later that you want it to go in milliseconds. All right. So here's something that will run after 2 seconds. All right, which is 2,000 milliseconds. Here's something in 50 milliseconds. What is that? That's 1/20th of 1 second. All right. It says there, this syntax defines a new function. You can call it whatever other function, you can call whatever function you want in there, or you can pass an existing function name and a set of parameters. Set timeout returns a timer ID, which is generally not used, but it can be if you need it to be. All right. If you specify a timeout delay of 0, the callback will be executed as soon as possible, but only after the current function execution. So notice here, we've got console.log before and a console.log after. All right. So it'll come down if this is the way that it's supposed to execute. Even though it's got 0, since it is a timeout, it'll do this, then come back and do that. As mentioned here, this is especially useful to avoid blocking the CPU in on intensive tasks. Set interval is similar to set timeout, but there's a difference. With set timeout, it's a one-time shot. With set interval, it'll keep running potentially forever. I've always given this particular example when we talk about that back in the old days, and let's see if we can even find one of these. Back in the old days, we had these wind-up alarm clocks that look kind of like this. All right. So you'd set it for 6 a.m. It's 10 to 2. At 6 o'clock, it would go off. You'd press the button here, and it would stop. That's a set timeout. Then over time, like about when I was your age, what started to come in vogue were things like clock radios. And with a clock radio, what you could do is the alarm would go off like this, but there was a button on there that was a snooze button. You could press the snooze button, and then it would go off again in 9 or 10 minutes, and you could press snooze again. That's more like a set interval. That's not a perfect analogy, but hopefully, at least in this case, it works. A recursive timeout starts a function every n milliseconds without considering when it's finished its execution. So if you want things to happen over and over and over again. It says if a function always takes the same amount of time, that's all fine. But if it has different times, all right, you can have it where one is basically impeding the other. And as it says, to avoid this, you can schedule a recursive timeout to be called when a callback finishes. And again, we're getting about as complex in here as you could imagine. All right. Now, rather than jumping in and talking about the node emitter or emitter, depending on who you listen to as far as the name of it, I am going to, for now, I'm going to stop, and I am at 22 minutes, so I'm going to stop in just a moment. When I come back, we're going to talk about the file system in Node.js. So I'll be back with that shortly.